Let's do some harder examples from section 9.4 that are more like what's in the homework. Hopefully we've sort of gotten the hang of it, but if not, we got a couple more examples. Let's try them. So this one says, given are the graphs of y1 equals x squared plus 2x minus 1 and y2 equals negative x squared plus 3. And they're graphed here, and they labeled them nicely. If you use desmos.com, and notice it even has a URL where you can look at this specific graph, it'll just have different colors for the two parabolas so you can tell them apart. But I want to point out that we should be able to tell them apart based on just the leading coefficients, because when a is negative, that makes an upside down parabola, and when a is positive, in this case positive 1, it would be a right side up parabola. So even if these weren't labeled, you know, I want to make sure we're able to tell apart, like, when is it upside down, when is it right side up. Part A, how many times do these curves intersect? Well, I'm seeing 2. So that's the answer to that is 2 times. And what are the points of intersection? Well, make sure it's x comma y is negative 2 comma negative 1 for the first point. And the second point, x equals 1, y equals 2. So most people get the points of intersection right, which is awesome. But where people struggle then is knowing what that means about solving the equation, because the whole point of this section is being able to take intersection points and saying that now this is where these two graphs equal. So we don't actually have to do the algebra here. We can just read from the graph that the x values where these are equal are x equals negative 2 and x equals 1. And that's it. So you could certainly like get 0 on one side, use the quadratic formula, but that is a lot of work and not what we're supposed to be doing in this section. We're just supposed to say, well, based on the points of intersection, these are the two x values where these two graphs equal each other. So let's try part C. I gotta make it up because I want us to do an inequality as well. So I want us to solve the inequality where x squared plus 2x minus 1 is greater than negative x squared plus 3. I'm using the same formula, basically. I'm just, instead of an equals, now it's a greater than. So before we are looking for where the two graphs crossed each other, now I'm looking for where the y value of one parabola is greater or above the y value of the other parabola. So where's the y values of the right side up parabola above the upside down parabola? Looks like this whole area right here, right? That those would be y values that are above the upside down parabola. And then over here too, y values that are above the upside down parabola. So now we just have to figure out how to write that in terms of an interval, because we're still talking about, well, what x values make this true? So the x values that make this true go all the way to negative infinity. That's what this arrow means over here, is negative infinity. And we always put a parenthesis on negative infinity. And then we keep going right to here. And we're talking about the x values when we're talking about a solution. So the x value here is negative 2. And because this is just greater than and not greater than or equal to, we're going to use a parenthesis for greater than. And then there's a gap, right? In the middle, the upside down parabola flips to being the one that's above. For this gap, we put a U. And that U stands for union. But it's just another way to say an or. So our solution is from negative infinity to negative 2 or, and then this other section of the graph goes from positive 1 and then to positive infinity. So the rest of the interval is 1 to infinity. So we just type a capital U in there to join these two intervals together. And that's all we're saying, right? I didn't have to use quadratic formula or any other kind of algebra on the final exam. It is really telling, like when I see a whole lot of work for these kind of problems, because it shows that you didn't understand 9.4. If we're given a graph, this should be really easy. We just read from the graph what the answers are. So let's try another one, make sure we got it. Given the graphs, so this one has a square root function, and then this one's just a straight line. This is y equals mx plus b. So this one's a line, and it turns out a square root function is a sideways parabola, but it's only half of it. But even if you didn't know what this looked like, you can tell that one's the straight line and one's the other one. And of course, you can also use Desmos.com if it helps you to see those graphs. What are the points of intersection? This one only crosses once. So the one point of intersection is the point -2, 1. Awesome. Easy. That's it. And then use this graph to solve. And we're looking for where the square root equals the line. Well, that just means the x value where they're the same, and the x value where they're the same, we just decided was -2. That's the point of intersection. The y value is, if you remember from the first video, the check, right? So if you wanted to check, yeah, let's check. That's a good idea. So if I plug in -2 on the left side, I get -2 plus 3. That'd be the square root of 1, which is 1. We want to know, does that equal to -3 over 2 times -2 minus 2? Those cancel. That'd be 3 minus 2, which is 1. So it checks out. So the 1 from this point is the sort of the check. It's the y value. But the answer to solve this equation is just the x. All right, last one, part C. I want to solve for where the square root of x plus 3 is less than -3/2 x minus 2. So this means where is the square root function below the line? Because this is the line. So where is this sort of half parabola on its side below the line? And so what I'm seeing, if I look at the graph, is it's from here to here. And that's it, right? That's where the square root function is below the line. So now we just need to talk about where the x values are. That's the solution, is the x values. And I'm seeing it goes from -3 to -2. But here, this one I picked to do in this video because it's a little bit tricky. The -2 I can't equal because we're not supposed to equal. We want to be strictly below, not equal to the line. But the -3 doesn't touch the line. It's not an intersection point. It's just where this graph stops. So where this graph stops is an endpoint that we want to include. So that's the only thing that makes this a little different. Because it's not an intersection point, it's just where the graph stops. We use a hard bracket to say that we could equal -3.